Hello everybody, my name is Bogdan Burcea and I'm a technical marketing manager at Infinet Wireless. Thank you very much for taking the time to join our webinar today. We are going to discuss about a set of the main protocols of mesh interconnection network technology called Mint, a proprietary technology of Infinet Wireless. The agenda for today includes 4 items. Firstly, we will discuss about the need of Mint development for Infinet products. Next, we will present the basic concepts of Mint. The third item is dedicated to the applications in which Mint makes the difference. And in the last item, we will conclude about the benefits of Mint. The products within the R5000 series of Infinet Wireless were designed as wireless routers, initially running RIP and OSPF routing protocols only, and being capable of creating any physical network topology, including point-to-point, bus, star, ring, mesh, tree, and hybrid. The aim was to replicate the concept of wired IP networks for the wireless networks. That's why the products within the R5000 series are natively IP enabled since their design stage, and they are natively capable of operating in a mesh wireless network topology. But the initial design of the R5000 series was found to have some serious limitations. Firstly, the networking configurations were quite sophisticated, and secondly, all nodes within a mesh wireless network had to operate at the same frequency and using the standard method of collisions avoidance, CSMACA, which was acceptable as long as the nodes could hear each other, but otherwise the hidden node problem was inevitably encountered. Another aspect was that the link metering calculation in case of OSPF was not adapting to the variations of the wireless link. In order to compute the cost for a wireless link, OSPF takes into account only the maximum bitrate related to a reference bandwidth which has a fixed value. Therefore, a new set of protocols had to be developed in order to overcome these limitations and to make the R5000 products suitable for complex deployments by addressing various challenges in a very efficient manner. And here the Mint set of protocols come into the picture. A switching engine was developed in order to ease the network configurations and operations and to allow sending data of non-routable protocols. A new routing engine was developed called Mint routing, also in order to ease the network configurations and operations and to adapt to variations of the wireless links. Polling mechanism was designed in order to have arbitration and streamline the operation of nodes in the wireless network, so master and slave type of nodes were added. But before digging into details about the main set of Mint protocols, an important mention has to be made. Although Mint stands for Mesh Interconnection Network Technology, the first word mesh doesn't refer to the physical network topology type mesh, but to the infrastructure mesh, which is a logical network topology designed according to the needs of the various applications. Regarding to the physical wireless network topologies, for commercial implementations, the only viable ones remain the point-to-point and the point-to-multipoint topologies. Mint is a collection of radio and networking functionalities, and as showed in the diagram, we can classify some of the Mint features as: among the radio features there are bitrate control and power control. Among the frame processing features there are bursting, compression, encryption. Among the networking features that ensure packet routing between the Infinet units, there are topology manager, link control, routing table, and from the point of view of the medium access control technology, there is polling technique. And now, for a good understanding of the basic concepts of Mint, let's take an example where a point-to-point link is connected to a point-to-multipoint sector through a layer 2 switch, and each of the two CPEs, as we can see in the picture, of the point-to-multipoint sector, as well as the slave unit within the point-to-point link, have a PC directly connected to them. Also, a fourth PC is connected to the switch. In the default configuration, Mint over radio is enabled as long as the configured radio parameters allow the radio link establishment. That's why we have in our example two mint areas as presented in the picture. A mint area can be viewed as a virtual Ethernet segment, and let's now understand the process of frames processing, passing from the Ethernet area to mint area and vice versa. The Ethernet frames received by an Infinet unit from an Ethernet interface are compressed according to the payload header suppression technique and encapsulated with mint layer to header. Then they go to the radio sublayer, where they are encapsulated again into radio frames, which are sent through a mint interface, PRF or RF, over the air. In case of TDMA, the mint frames are converted into time chunks with byte resolution. TDMA adds its own header and then sends the frames out through a mint interface. At the opposite side, mint frames received from a mint interface are decompressed and decapsulated by stripping the mint header and restoring the Ethernet frame if the frames has reached the destination. Otherwise, the frames are routed by the mint routing engine, hop by hop, towards the mint destination. And now let's go back to our example where two mint areas are available, and let's add into the picture the switching mechanism. At the R5000 series, switching is performed within the switch groups, which are nothing else than special containers that filter the data according to specific rules and act like transition points between the mint and Ethernet networks. Traffic can be switched only between at least two ingress-egress points. For two Infinet units to switch data between them, they need to have the same switch group number configured. As we discussed, a switch group is a virtual switch with filtering capabilities for the traffic arriving from the Ethernet network. And before entering into the mint network, the packets are assigned to specific switch groups, which won't be changed by any other mint node along the way. Let's suppose in our setup that we want to allow communication between PC1 and PC3. In the default configuration, each unit from the R5000 series has the switch group number 1 enabled. Ethernet 0 and the RF5.0 interfaces are added to it, so the traffic is switched between the Infinet units without the external intervention. Therefore, the traffic between PC1 and PC3 is allowed without the need to change the default configuration. But what's going on in case we delete the default switch group 1 at the master and slave unit and create switch group 2 instead, still adding the Ethernet and RF5.0 interfaces to it? Well, we will notice that the traffic is also allowed, because once the packet sent from the PC1 towards PC3, they leave mint area 2 and enter into the Ethernet area. Thus, the mint header that is tagged with switch group 1 is removed at its point, and as we've discussed before, and next, once the frames arrive to mint area 1, they are tagged again, but at this time with switch group number 2 set on both master and slave units. Let's now join mint area 1 and mint area 2, and in this case to create an extended mint area over the Ethernet segment. We have to create PRF interfaces at the base station and master units, and also to join the RF interface with the PRF interface at both units. Now we have only one mint area, so the packets sent from PC1 towards PC3 are carried into switch group 1 entirely through our extended mint area, and they can exit this mint area at the slave unit in order to reach PC3 only if the slave unit has switch group 1 configured, as every Infinet unit learns which are the other units that have the same switch group configured in the same mint area, thanks to the switch group discovery protocol of Infinet. Otherwise, the traffic between PC1 and PC3 won't pass entirely through our extended mint area, and we will see immediately why. Therefore, we define as mint interfaces the radio and the pseudo radio interfaces as mint interfaces. The pseudo radio interface is a virtual radio interface created over Ethernet interface, which is its parent, and the link between the two PRF interfaces is nothing else than a layer 2 tunnel over layer 2. Thus, Mint areas are bordered only by the PRF or RF mint interfaces. In our last configuration, the master and the base station units perform only mint routing of the frames received from CP1 and slave. There is no switching performed with the external network through the Ethernet interfaces at this level, so the communication takes place only through the PRF interfaces. Let's now see what is changing if we configure switch group 2 back on the slave unit. Well, we still have one mint area, but PC1 and PC3 cannot communicate through our extended mint area, as I said before. However, the path through the Ethernet interface is enabled because the slave unit has now the same switch group number like the master unit, and in this case we have a different data flow like the situation before. So the mint frames are transmitted into switch group 1 between CPU1 and base station. Then the mint frames are reconverted into Ethernet frames, so they leave our extended mint area. They are switched through the Ethernet interface at the base station. The master unit receives the Ethernet frames and converts them to mint frames with switch group 2 this time. So the communication between PC1 and PC3 and vice versa works, but through Ethernet area and not entirely through our extended mint area. Let's now see what happens if we configure the same switch group on all units. Well, in this case we have two paths active, one through the Ethernet interface and the other one through the PRF, which means that loops will appear, and for this situation the spanning tree mechanism has to be enabled on all Infinet units at the level of the switch group. Spanning tree blocks switching at either the master or the base station side, and the Ethernet path is not available anymore. Let's now discuss about a few aspects which summarize the ideas that we have showed before. We can conclude that Mint operates between layer 2 and layer 3 of the OC reference model. Mint routes the frames to the destination hop by hop, and it knows the topology of the network like a classical layer 3 routing protocol, with the particularity that the routing is performed based on the destination MAC and the gateway MAC addresses and not based on the destination and gateway IP address. Mint routing is an alternative to classical layer 3 routing protocols, being especially useful as the quality of the radio link is changing all the time, and that needs to be taken into account. The routing module of Infinet Wireless units does not need to be enabled for ensuring the data transferred through the Mint network. It relies only on the switching module, which is by default activated too. Switching takes place only at the source and destination nodes. The frames are switched from one port of a switch group to another port of the same switch group, whereas Mint routing is performed hop by hop, based, as we have discussed, based on the destination MAC and gateway MAC, and each unit has to determine the best path to reach the destination. Let's now review a few applications where Mint set of protocols bring huge advantages. And in case of the mobility projects where CPEs are installed in the mobile vehicles, which are constantly change their connectivity with different base stations along the way, without an intelligent mechanism to ensure fast handover and permanent connectivity at a high quality, we couldn't address this kind of projects anymore. But thanks to the Mint set of protocols, we can successfully do it. Another type of application is backup wireless links. We can use Infinet Wireless links as backup links for primary data connections, like fiber optic connections for instance, simply without having the need to add extra network devices to implement such configuration. The entire job is performed by the Infinet unit regarding the path selection of the packets and also regarding the failover task. Or in the next examples, we can build different configurations to provide full duplex communication between two endpoints while maintaining the benefits of redundancy. This is possible by adding extra Mint cost from the settings. In this way, two endpoints can send and receive packets simultaneously, doubling the actual throughput, and still, in case that one link fails, the other link will take over. The communication of the entire system becomes half duplex, but the redundancy is still ensured. And other examples from this category. Now, regarding the benefits of Mint, we can sum up the followings. Automatic Mint node discovery and dynamic routes to all Mint destinations. Each Mint node constantly updates the full Mint map of the network, containing the Mint neighbors and the routes to all Mint destinations. Mint costs and link quality assessment. Mint costs are constantly calculated by each node depending on the type of the node. For instance, for the fixed nodes type, the interval is 3 seconds, whereas for the mobile nodes type, the interval is 1 second. Mint cost calculation depends on many parameters like SNR, bitrate, percentage of retries, link load, throughput. Loop-free capability. The network path is computed for each and every frame within a stream of frame data, and therefore it's not possible for a routed Mint frame to return back to its source via a different path. In case of layer 2 remote management, which is also allowed thanks to Mint set of protocols, in this case Mint enables sending and execution of any CLI command from the local unit to the remote unit in a Mint network via both web GUI and CLI environment. The only thing that we need is an active link with an adjacent Mint neighbor, and in this way we have a Mint power link through which we can access and control 100% the remote unit. And of course the redundancy, because Mint deals with data frames sent via multiple network paths, this capability allows the implementation of redundancy configurations using multiple parallel connections between one endpoint and another, as we have seen before. That completes our agenda for today. Thank you once again for your time and see you during our next webinar.